So as you may or may not know, I have a couple of solar panels and a small wind turbine which I use to charge a big 12-volt battery, and then I can use the energy from that battery to do all kinds of useful things like charging up my phone or my laptop or even charging my electric bicycle. Now the problem is that every now and then the situation occurs that it's very sunny outside or there is lots of wind or both, but the battery is already fully charged and I have nothing to use all that energy for because, my phone's already full, my laptop's full, my electric bike is full, and so I have all this sunlight going to waste. And I've been thinking I need a solution to overcome that problem. And what I've come up with is that what I need to do is I need to find a way of feeding that excess power back into the power grid so that it can power the rest of this house. Now in order to do that you need a device that's called a grid-tied or grid synchronized inverter. And of course I could buy one of those, but that would be boring, so instead what I'm going to do is make one myself. And that's what you're looking at right now. A grid synchronized inverter is actually quite a bit more complicated than most people think, because it's not just a normal dumb inverter. So because it's kind of complicated, I'm going to split this into two parts, right? First of all, we're going to build an inverter, because that's difficult enough on its own, and then once we get that to work, then we're actually going to make that grid synchronized. Or we're going to try to do that, because at this point I don't know if it's going to work. I have a method in mind of how I'm going to do it, but I'm not sure if it's going to work. But first of all, today, we're going to just build a dumb inverter. So this is the circuit diagram for the inverter that we're about to build. And as you can see, it consists of very little parts, right? There's just a transformer over here, and these two MOSFETs. And that's all there is to it. Those are all the essential components in this circuit. And then, of course, right here, we've got a 12-volt battery, which is our power source. So the way it works is that when I turn on this MOSFET at the top right here, the electric current from the battery will go into the transformer, like so, then up through this winding right here, and then through the MOSFET back to the negative side of the battery, like so. If I turn on the MOSFET right here, I close this one again, I turn on the MOSFET at the bottom, then the electric current will go down here in this direction through this MOSFET and then also back to the negative side of the battery. So by turning on either one of these MOSFETs, we can control the direction of the electric current in this transformer. We can either send it up or we can send it down. So if we alternate between those two states, the current will go up and then down and then up and then down, and it'll keep switching direction. So we're producing alternating current, right? Current that goes back and forth, or in this case, up and down. And then our transformer will transform that up to a much higher voltage, and it'll give us right about 240 volts AC on the output. And then here is where we can connect an AC appliance, or in the future we can connect this to the grid and use this system to feed electricity back into the grid. But again, that's for next video. Now obviously we're also going to need something to drive these two MOSFETs, right, to turn them on and off at the right moments. So what we're going to do is we're going to connect these MOSFETs to a little microcontroller, which is going to be an Arduino. So the microcontroller controls these two MOSFETs. And also, just to make sure that the MOSFETs turn off when we want them to, we're going to add some pull-down resistors to them as well. Finally, we're going to add a potentiometer to this microcontroller, which will later on give us some more control over this inverter, but you'll see how that works later on in the video. Okay, so now we've got our circuit board fully assembled, so you can see we've got our two MOSFETs over here, and then the microcontroller which is going to drive those two MOSFETs. And so the next step would now be to attach this circuit to the transformer that we talked about earlier on. But before we do that, we need to program this microcontroller to properly drive these two MOSFETs. And now I'd like to talk a little bit about how we're going to do that. So the easiest way to drive these MOSFETs would be what I already explained, to just switch between them. So we start by turning on this one, then we turn on this one, then we turn on this one again, and we just keep going back and forth. Now that's going to produce an AC output that looks like this. It's a square wave. But that's not what the AC from the power grid looks like, right? Because the AC from the power grid is a smooth sine wave that looks like this. So now the question is, how do we get this to look a little bit more like this? Well, what we can do is we can introduce a little pause in between, switching between these MOSFETs. And so now we get a waveform that looks like this. So it's got these pauses in there that make the wave a little bit less square and a little bit more like this. It's still quite blocky, it's not quite perfect, but it's more like a sine wave than this pure square wave that we had before. Now there are ways to get an even cleaner output that's even better, and we're going to talk about that in the next video, but for now we're going to use this method for our inverter. So what I'm going to do is I'm going to upload a piece of software to a microcontroller that'll do this, and then we get this thing wired up to a transformer and see if it actually works. Right, so as you can see, we've attached the circuit board to our transformer, which means that now if we plug these two wires into our 12-volt power source, in theory we should get 240 volt AC on the output. So let me just plug in the microcontroller to my laptop so that it turns on. There we go. Now we plug these two wires in here. Like that. Let me just measure the output voltage. So you can see that right now we've got about 62 volts AC, which is of course not what we want. But this is where the potentiometer comes in that I installed. You see, what that potentiometer is going to do is that when I turn it, it's going to change the shape of that square wave that we talked about. So when I turn the potentiometer this way, it's going to make those pulses wider, increasing the effective voltage, and therefore increasing the effective output voltage as well. So I'm just going to turn this a little bit. Now we're going to measure it again. You can see now we're at 173 volts. So now we're just going to keep turning that potentiometer. And you can see right now we're at about 240 volts. We can also turn it even further and get an even higher output voltage, but we're not going to do that. I'm just going to set it to 240. There you go. So now the inverter is actually working, which means the last thing that we need to do to test it is to actually connect some kind of AC appliance and see if it's actually capable of powering anything. So right here we have the power inverter, and I've got a table fan, so we're going to connect the table fan to the power inverter, and then hopefully the fan is going to spin. So I'm just going to put this fan, where the hell I'm going to put this fan, let me just see. Now one thing that's kind of annoying is that of course it's got a normal power plug which doesn't really fit on my inverter, so we're just going to grab a piece of wire. Right, so now we have a power plug with a wire attached so that I can connect it to this inverter. Let's turn it on. Here we go, plug in the negative and the positive. Right. There we go. It's running. So it's not spinning very fast. I think we need to increase the power level a little bit, because of course the output voltage of the inverter will drop a little bit when you apply a load, so we just need to increase the voltage a bit now. There we go, give it a bit more juice. It's working. Right, let's just turn it off. So as you might notice, the fan is making kind of a loud buzzing sound, and that's because we're driving it with the square wave rather than with a normal, actual pure sine wave from a real power outlet. But the good news is that the inverter is actually working, and so in the next video we're just going to optimize it a little bit more, make it a bit better in general, and then we're going to try to make it grid synchronized. Anyway, I hope you've enjoyed this video. And of course, thank you for watching.